All right, it has now reached the top of the hour. It is time for this week's presentation from the DBA Fundamentals group to start on its glorious path. All right, so today's presentation is on data warehouse or data lake. Which do I choose? It's brought to you by Rachel Pedreschi. I'm sure I massacred that name, but it's probably not the first time. Probably won't be the last either. Today is November 1st, 2022. Thank you all so much for joining DBA Fundamentals presentations again. In the top right-hand corner of the screen, you should see the three names of the leaders of the DBA Fundamentals group: Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If you have any need to get hold of us, please reach out to us on Twitter, where you can find our Twitter handles there right next to our names. Below that is all the ways you can reach out to us on social media. First off is a meetup where you've probably found most of us today fairly easily at least. On there you'll find all of the link to our next presentations. We have most of them, I think, have some set up through at least early next year. So please reach out to us on there and sign up for any of those you want to go to. Please reach out and show as many people as you can so we can get started and bring the joy to others. Below that, you'll see our website, dbafund.org, where we have all of our past presentations, our future presentations, and all kinds of things in between. We have our archives as actually back until 2013, so we have lots of goodness out there. Below that is our link to our version of YouTube, DBA FunTube. It's obviously the most fun that DBA can have on the web if you're into presentations. Be sure to actually like our YouTube site, because then you can see all of our presentations as they are actually published to the web, so that you'll know the minute that we have today's presentation as well as any of our upcoming presentations. Also, you'll notice below there is Twitter, our Slack channel, and our LinkedIn channel. Be sure to follow us on all of those so you'll see all of the goodness. Also, today's session is being recorded, so it'll usually be available within 1 to 2 days. As I said earlier, be sure to check us out on our YouTube channel. Also, please remember to turn off your video and mute yourself unless you're the presenter, so that we can actually focus all of our attention on you, as we want to focus on them, obviously, and learn as much as we can. And if you have any questions, please be sure to type it into the chat window. We're trying to run an interactive thing here, so please ask as many questions as you'd like on this topic, obviously. Yeah, and be sure to ask. Yeah, don't worry, all good. Yep, and with that, we go to Rachel. I have a very small bio. I'm sure she has a much better bio. And with that, over to you, Rachel.
Oh, thank you so much, Kevin. I super appreciate it. Let me go ahead and say what everybody has to say, which is, let me share my screen. So hi, again, thank you all for coming today. Today's session is going to be on data warehouses or data lakes. Which do I choose? So why should you even listen to me? My name is Rachel Pedreschi. It's usually pronounced Rachel. How do you pronounce your last name? So you did perfect, Kevin. Thank you. I've been in databases for 25 years, more than 25 years now, which is, means that, the makeup has to become heavier every time I do one of these presentations. But I started off in the 90s with a company called Redbrick. Redbrick was a database that was built for data warehousing. I'd love to see any hands of anybody who might have remembered good old Redbrick. But Redbrick was bought by Informix, and then Informix was eventually bought by IBM. So I went through those acquisitions and got to learn most of what I know about databases from Redbrick. So I moved on to becoming a DBA for a company called Vail Resorts, and did a lot of interesting work with skier days and marketing to front range people versus non-front range people. And then from there, worked for Business Objects and Jaspersoft on the reporting side, and then went back into databases with Vertica, Cassandra at DataStax, Druid with Imply, and now I'm working with Presto at Ahana. So for the most part, most of my career, I've been on the vendor side of the business, but DBAs and databases.
My microphone is off or on.
Databases are near and dear to my heart.
Yeah.
So what are we gonna? So why do I think this? Why did I want to present this particular topic? I do think there is a lot of questions out there because as you know, about 10 years ago, there was a what I call a Cambrian explosion of databases. And a lot of the databases that came out of that time, out of the relational world, were for like NoSQL databases. But another thread started on the OLAP side of the business, which is these data lakes and Hadoop. And then there was Presto and Dremio, and it's an extremely crowded, but really interesting market. And so when I started working with Presto, as a database practitioner, I became really interested in like how really databases are kind of decoupling themselves. So anyway, that's what I want to try to get across today is what is these new architectures? How do they compare? Where would they might fit into your world? And we're going to go a little bit into the architecture of Presto, not too much, but we will get there too. Oops, that was my agenda slide. Sorry about that. And I think Kevin's going to interrupt me if there's any questions. So I'm really happy to make this more conversational. And if you want to know how any of these things compare to any of the other systems out there that you might have heard of, I will do my absolute best to try to describe that to you. All right. So we're going to start the talk with the traditional data warehouse. And some of you might, again, like I mentioned, used Redbrick, or Oracle became fairly commonly used as a data warehouse, or Teradata, and then the newer distributed systems like Vertica. But then, you know, we now went into the cloud, and you might see the traditional data warehouse being a Redshift or a Snowflake. And these are relational databases, which are great for doing joins and supporting star schemas. They're typically, at least nowadays, a more columnar structure, so that data is stored in columns for fast retrieval. It's very structured. So this is going to be very much a what I call a schema on write type of system. And meaning that ETL is, as always, the most important part of any data warehousing strategy. And you access the data through SQL. Some of the challenges of it are that they can be expensive and difficult to manage. So when I think at the time of the web and mobile applications, there became a lot more data. That's when big data became the kind of the buzzwords. And you had to start making choices if you were going to be building a data warehouse on what type of data you were going to be putting into that data warehouse. You kind of had to choose, like, what are the first class citizens, which of course then meaning, I think at the time Gartner said is going to take 18 to 24 months to build an enterprise data warehouse. Well, if you can think of your organization 24 months ago and what questions it wanted to ask, they're very different than they are today. The whole economic and social world has changed. So trying to manipulate data in order to build an enterprise data warehouse in a timely manner was extremely expensive, extremely difficult. And again, because you were trying to manage costs, you might limit the amount of data that you had access to. And we're going to talk a little bit more about how about data lakes and Hadoop in a little bit. But for the most part, to define a data lake, if you're not already familiar with it, it's much more of a schema on read type of system where you put the data in some semi-structured format. And what I mean by semi-structured is I mean like JSON or XML format, not I don't mean semi-structured by videos or pictures or anything like that. The data lake became almost synonymous though with data science. So Notebook and Python Access had was the you could do that very easily on data lakes. And you could just throw your data in there. There was no need for really heavy ETL, and not surprisingly, a lot of these data lakes became what I like to call a data swamp. So there was a lot of data there. It wasn't very well managed, but and then things that became so good things about it, like being able to do data science and being able to access it with notebooks and Python, also became a limitation because not everybody in the organization uses those particular tools. So I'm going to break things down a little bit. So, and I'm going to check for any questions. No questions? Okay. So what do we need to do? Well, what is a database at the end of the day? I mean, I know I'm oversimplifying. There's a lot more to it, but we're doing it in wide swaths. You have users and you've got data, and data is stored on disk as files. Then you need some way for those users to talk to the data. And mostly in a world of database or in analytics, that's going to be SQL. Now, I know there's other flavors out there, but that is the de facto standard. In order for SQL to work with the data, there needs to be some sort of abstraction that organizes the contents of those files. And we like to call those metadata tables in traditional databases. We all use them. Then you need some type of system that authenticates users and authorizes them to do stuff. So any RBAC or single sign-on. So if you take this whole system together, again, in a very wide swath, we'll call that a data warehouse. That is what a database is really. It's those components, and you can call it a data warehouse. But people are asking, where can we save money on these systems? And hold on a quick second. We can take where the data is stored and we can separate that out. And we call that now the data lake. So if you want to look at what I described earlier as the data lake, that's the section of the data warehouse, is that data storage on disk. Now, in a data lake, you can store data in formats like Parquet or ORC, and those are columnar formats that are open standards that are ideal for doing analytics. This data lake storage, like I mentioned earlier, is it allows you to leverage modern compute infrastructure, particularly within the cloud. And it's scalable. So instead of buying a fixed box where you have fixed storage, you can leverage the cloud and be elastically scalable. You can extend it. You can go buy additional drives on a fixed appliance, but in the cloud, it's fairly low cost. It's elastic. And the amount that you're paying for the storage is relatively cheap compared to the specialized hardware that you'd have for these appliance types or these on-premises data warehouse. So these are two big properties of this modern data lake, is that you've decoupled the storage, is no longer tied to a particular engine because it's in these open formats, and it allows other engines to read that same data. So you don't I mean, you're not just limited to SQL processing. You could do machine learning on this, like I mentioned earlier, Python and notebooks. But these open formats do allow for scalable. So one of the first systems, if you're familiar with this ecosystem, is Hadoop. So you can say that kind of in the mid 2000s, Data Lake 1.0 was HDFS. So we could store a bunch of files, and it was scalable because it was a distributed system. It was relatively cheap because you weren't using specialized hardwares, and this was very novel at the time. You could dump you can just dump all your files in there. You could create directories and rename directories, and this really did usher in the big data world. More recently now, the cloud, there's object stores, and the object stores have emerged as the more standard in the cloud. They're much simpler than file systems. They have a file system like hierarchy, but they have a simple API where you can do things like put objects, get objects, and delete them. For Amazon, S3 is probably the predominant object store. Last time I checked, it had 100 trillion objects worldwide. And because it's gotten to that size, has demonstrated its scalability, its durability, performance, and all that, and it's relatively cheap. So you can store data for about 0.023 cents a gigabyte, and you can get it even cheaper. And there's even more colder storage. So data lakes now have evolved from HDFS and Hadoop systems to object stores, and S3 is a good example of one of those object stores. And this is the interface if you're not familiar with it. All right, so let's go down to the next portion, the metadata tables. There's two ways that you can replace these metadata tables if you're trying to, if you want to make your data lake more of a data warehouse. And one is Hive. So again, that's from the Hadoop ecosystem, but that meta store allows for translation. And then in Amazon, there's a system called Glue. So if you're not familiar with Glue, it's basically creating metadatas and allowing you to build tables off of data that sits in S3. For the system that authenticates itself, there are lots of tools like Apache Ranger out there that are open source. And in the Amazon world, you could use something like Lake Formation. But this last little piece is what's missing at this point, right? So we've got an ability to deconstruct our data warehouse in the cloud or an open source to save money. But we do need a SQL engine. And this is where Presto comes in. So Presto is an open source project, and we'll talk about it in a little bit. But this is what I want to call the open data lakehouse. So we've merged this concept of a data lake and a data warehouse together, and we've created an open data lakehouse, which will have the good characteristics of both types of systems. So you've got all of the openness and the ability to use Python and notebooks in the data lake. You've got cheap storage there in an object store. You've got elasticity. You've got scalability. You've got failover. And then the other pieces that an enterprise data warehouse provides, like security and a catalog system, you can use through open source projects, or in Amazon, they have tools for that. Similar ones in Google and Azure. I'm not as familiar with those. I apologize. But pretty much you can recreate any of these databases through your own sort of data lakehouse. One thing that I don't have on the slide, though, is table management down at that data lake level. So as one thing that a database does provide you is that you can do CRUD style operations, creates and updates and deletes. And in a data lake, you're going to have to manage that yourself. So some of the projects out there that help manage that are Iceberg and Hoodie. And those will allow you to create versions of those tables and manage more of ACID level transactions on those underlying data lake files. And in this particular case, a lot of times we see the ETL tools that are being used, Spark, which I know you guys are having a talk on in a few weeks, or Flink. Sometimes you see Kafka, for example, and all of those transport systems do support writing data to the data lake in Parquet or ORC format, and then using table formats like Iceberg and Hoodie to manage those transactions. All right, so I'm going to pause here before going into a little bit more about Presto. Is there any questions?
No questions as of yet.
Okay, so far so good, everyone. Any raise of hands? All right, cool. We are going to go. Now we're going to go back to the world of HDFS. So before I get into the details of Presto, I want to talk about how it came about. So, why did it appear, and what was the story behind it? So we talked about Hadoop earlier, and the Hadoop, the HDFS, the Hadoop distributed file system, the data lake 1.0. But the way that you would process data on Hadoop or the HDFS was to use Hadoop Compute, which was called MapReduce. And all it did was read the data from HDFS, which is a distributed system. It did an algorithm called map and then an algorithm called reduce. So you have different splits of data. You can do some function on that split, shuffle them around, because you might need to share data across different nodes to do the compute you want. And then it has a reduce phase. You get some data set, it writes back to the distributed file system. The replication happens only because you want fault tolerance. Because one thing you do want to keep in mind with commodity hardware is that you need to consider failure of first-class citizen. So that if the node goes down, that the data is still available. So this was all the rage when you wanted to do stuff in big data in Data Lake 1.0. But writing MapReduce was pretty painful, and not everyone's a Java program, and everybody knows SQL. So that's where Hive came in. Hive was open sourced in 2008, and it was created by Facebook. And it was basically a SQL-like dialect on top of Hadoop. So you would here's the block diagram. You would have some clients, you would have some servers, and they were able to attach to the cluster, or the Hadoop cluster. It had something called a metastore. We mentioned that earlier. And then you could select something from like a table like transactions, and it could give you a SQL-like interface, and underneath the hood, it would translate all the MapReduce for you. And this was cool, and it worked, but they wanted to do better. So this is how Presto evolved. Presto is essentially the successor to Hive for large-scale SQL, and it re-architected things so it didn't rely on MapReduce. It has an in-memory architecture. It's really low latency. It was also created at Facebook or Meta, which where Hive was, and it was introduced in about 2013. So it took about 5 years for Facebook to decide that SQL was probably a better idea, or native SQL was probably a better idea than underlying MapReduce. It's got a pretty big community at this point. It's open source. It's distributed. It's designed from the ground up for fast analytic queries. So you can query. You can also do federated queries with Presto. So not just query data that's sitting in S3, but you can also query data that might be sitting in a MySQL system or an Oracle system or an Informix system, and you can write one query that joins against all of those. So Presto is a really cool piece of technology that will allow you to unlock value out of data that's sitting in a data lake that you might already exist, or you allow you to create a data lakehouse that allows both SQL and federated type of queries. All right. So this is a, oh, sorry, I got ahead of myself. at a very high level, this is the Presto architecture, and we're going to get into a little bit more. But you've got coordinators and you have workers, and those workers will go out to query any of the data that you see below and more. We're actually going to be having a PrestoCon in about a month out here in San Francisco, and we're actually going to be helping you build your own connector. So if you have a database system, like I know a client of mine wants to use SQLite, I think DuckDB is the new cool kid on the block. So if you want Presto to be able to query, say DuckDB against MySQL, or Cassandra against MongoDB, which doesn't make any sense in my world, but hey, you do you. And then you can use any of your typical front-end tools as long as they have a JDBC connection to access those data. So it's a very flexible, very useful, different type of tool. Some of the use cases that people use Presto for, it is in memory. So it is actually very good for interactive and ad hoc querying. You're talking about results usually in less than a second. If you need sub-second results, I'll be happy to talk about some of the options there for sub-second results in analytics type of systems. Reporting and dashboarding, this is probably the #1 use case. I think I mentioned federated querying across different data sources. But then you can also use it to do, I guess probably better say ELT. So do transformations of the data that's already sitting in your data lake to new files or new tables, and you can use that as well using SQL.
So Rachel, we
Yeah.
do have a question before you go on.
Yay.
You may answer this one later on anyway, but all good. How does Presto compare and or relate to Kafka?
Oh, good question. All right. I'm not going to get into that, but I will definitely talk about that. So Kafka is and Confluent would get really mad at me if they heard me say this, but for the most part is a message bus. And it's more than a message bus. It does cool things like provide exactly one semantics. But Kafka is a way of keeping your different databases in sync. So you might have an application, let's take Uber, for example. Uber uses Kafka, and they take data that's coming from their app, and they use Kafka to span it out. And I wish I had my Uber reference architecture on this deck, but I don't. So then they use Kafka to say, all right, you get, Presto, you get this data for doing the internal reports. Pinot, you get this data for doing in-app analytics. And then we're going to put this other set, and then we're going to use this other data to run into a different system to do billing, for example. So Kafka, you can think more as a transport mechanism. It's more of a pipelining type of tool. You can query it, and there's something called KSQL DB, but it doesn't store the data for very long. Presto, on the other hand, is a query engine. It has a JDBC connection. It sits on top of either databases or data that lives in S3, or in a data lake, and allows you to query and federate the data across those. Did that answer your question?
I believe it
I
did.
think it did, but I'm not sure. This is all still pretty new to me. Thank you.
Yeah, no worries. It's there's been like I said, there's a Cambrian explosion of databases about 10 years ago. And it's, basically it's my job to keep on top of all of this stuff. And I can't even imagine if you had a real job to do, and this wasn't what you were trying to do. Every day I learned about a new one. But Kafka is more all over the place rather than just for analytics. I would say Kafka is there to keep microservices and these individual databases all in sync, where Presto is much more of a replacement for a database. Well, it's a query engine.
That helps. Thank you so much.
You're welcome. Anybody else? Now that we had somebody, anybody?
break the ice. No, so far, I think everyone's at least tracking, which is important.
Yeah, and I saw one. By the way, Amazon moved from Presto to Trino, and I think that they did. And I'm happy to talk more about that. The difference between Presto and Trino. Actually, I might as well, since it was brought up. So Trino is Presto. And this gets into a little bit of, what do I want to say? Open source politics more than technology. But a few of the original authors of Presto at Facebook wanted to monetize Presto. So they created a company called Starburst, and they started, and Facebook was like, yeah, no, you're not going to do that. So they forked the project. And so there's Presto and there's Trino. And this is for people who know this world. And they're, for the most part at this point, identical. It's just that Starburst has put a lot of money and resources into building out the Trino community, brought a lot of people over to using Trino versus Presto. But in terms of use cases, Trino and Presto are, for the most part, the same thing. There's little differences now in functionality, but for the most part, they solve the same problem. And yes, Amazon did actually just move to Trino. They made that decision about 1.5 years ago, because at the time, Facebook wasn't doing much with Presto in terms of the community. So they followed the founders to Trino. But Presto is the underlying technology here. Okay. Oh, speaking of which, could have just talked about it here. So there is, Presto is an open source project. It resides the Presto Foundation, which sits under the Linux Foundation, and it has an open source kind of governance. And a lot of people like that. Trino is also an open source project, and it has a different governance structure. Okay, so why Presto? And let me make sure I've got all the questions. Okay, so why Presto? First off, it's scalable. It's a distributed architecture, and it's very low latency. So it's good if you want to have interactive queries. So if you're trying to query terabytes of data, but you don't want to wait hours to get your answers, this would be a good option because it puts the data into memory. Presto also has a cost-based optimizer in it. So if you do play around with Presto, you can do and explain like you would with an Oracle or any other database, and it will show you the optimizer plan and where it's pushing down predicates into the underlying data sources and where it's doing any types of shuffling. It's pretty cool. It's made plugging in multiple data sources first-class citizens. It doesn't just use any old SQL dialect. It's ANSI SQL. So there's really no learning curve. It works with JDBC, and it's an open source project. So I'm going to go a little bit more into the details of the Presto architecture. Any other questions so far?
No further questions.
All right, Kevin, is this the right level, or would you like any changing?
Nope, you're doing perfect. Rock on.
All right, let's keep going then. Okay, so let's double click onto the architecture. What's under the hood? I alluded to earlier that there's 2 types of processes in Presto, which is very common for distributed systems to have something that's the brains and coordinates all the work. And in the case of Presto, somebody had a lot of imagination and called that the coordinator. And the coordinator is the thing that connects to clients. So if you have a CLI tool, if you have a BI tool, whatever JDBC connection, it actually connects to the coordinator. And when you write a SQL statement, the coordinator is what parses that plan, creates it using the cost-based optimizer, and then manages the work to the workers. And again, because somebody had a lot of imagination when naming them, the workers are what do the work. They're the workhorses. They're the ones that actually take their tasks from the coordinator. They go ahead and fetch the data they need to fetch, and they do whatever processing they need to do as instructed by the coordinator to fulfill the SQL query that the user wants. So in terms of scalability and how you would, how would you manage this, for example? So a coordinator would be, and I'm going to speak EC2 for those who know it, but you would pick a single smallish instance as a coordinator, and your coordinator scales up as you add workers. So one coordinator should handle about 500 workers, about up to 500 workers, and you can add more coordinators. It's actually, if you want to look into that, if you're interested in those details, it's a project called Project Fireball, which is like the coolest name for a project ever in Presto, but allows for multiple coordinators. The workers themselves should be memory optimized, and those you scale out. So as you need more capacity, lower latency, you're querying more data, because remember, all this goes into memory, and this is a Java-based application, so you're going to have enough JVM for everybody. So those workers, you scale them out. So another aspect to Presto that you would need to understand is the notion of a connector. Presto exposes, it's the interface to the data sources. And this is what creates the table abstractions to the underlying data source. So this is how it does this federation. So when you connect a coordinator, it's basically saying, okay, what underlying database am I going to be going to, and how do I access the data? So for example, with Cassandra, it knows how to read Cassandra tables properly. So it's going to make sure that that it sets up the query that you give it properly under the hood for Cassandra. And it can actually connect to Kafka. So I know I had a question earlier. You could be joining Kafka, for example, with SQL Server. So if you were using Kafka for CDC, like I saw earlier, and you wanted to connect it to data that's already living in SQL Server for some reason, you could use Presto for that. Let's see. So those connectors are kind of a shell. They're basically saying, all right, these are the instructions on how to access that underlying database. So when a query does come in that accesses that database, it's going to know how to do it. This is a little further detail. I'm not going to get too much into it, but the coordinator does have a bunch of sub modules that take care of the query, that processes it. We talked about how that it has an explain plan, and there's a scheduler because it's a distributed process. So who do I give the tasks to? You got to start coordinating with external storage systems. So this is a little bit more details. All right, my last section is on real world use cases, and then I'm going to open it up to you guys. Blinkit is an instant delivery service. They actually moving off of Redshift to an open data lake because they have over 200,000 orders a day. So they actually chose to move away from Redshift due to the cost, but they needed to be able to handle quite a bit of data and be able to get everything delivered within 10 minutes. So this is an example of them moving from Redshift or a data warehouse to this more open data lakehouse concept. And then Securonics is one for security hunting or threat hunting. And they actually moved from Athena to my employer Ahana, which is a hosted version of Presto, with to get better price performance. And we can talk if you're interested in more about how Athena is packaging Presto or Trino, and the goods and the bads of that. I'm happy to go into that as well. Okay, I think I hit 40 minutes almost exactly. So what questions can I answer? Where else can I go? What else is the group interested in? Oh, ClickHouse. Great question. Can you share your view on ClickHouse in comparison to alternatives, pros, cons, and proper use cases? Yes, I'm happy to talk about that. Okay, so I would say ClickHouse lives in a world of it's an OLAP database, so it's not an OLTP database, but a database that does analytical processing. And the way that I define that is it's going to scan a lot of data versus doing small inserts and reads. So I narrowly define OLTP versus OLAP by OLTP does very small reads and writes, and OLAP does very big reads and writes. There's three. Presto is an in-memory against a data lake or a federated database. This is for use cases that are, about a second. You use ClickHouse and its ilk for sub-second response times. So ClickHouse is a database. So you take data out of the system, your source system, you ETL it and you load it into ClickHouse, and ClickHouse is going to store it onto disk in its own proprietary columnar format. ClickHouse, Druid, and Pinot are very, very similar architecturally, and they're very similar in what use cases they solve. And they, in my experience with Druid, which is a ClickHouse competitor, I would say the people who got the most value out of Druid were using it for in-app type of analytics. So Uber uses Pinot, which is again one of the similar ones, to be able to provide analytics within the Uber application. So any types of data that you see, I think about the drivers, how far drivers away from you, that's using Pinot. And you can only imagine how quick those queries have to come back, but they have to scan through a lot of data to do it. ClickHouse came from Yandex, and it came out very much for doing clickstream analysis. Druid came out of MetaMarkets, and it was designed for ad tech. And Pinot came out of LinkedIn, and it was designed for more event type of analysis. So three very similar use cases, and all three of them have their strengths and weaknesses. And I would definitely say, take a look at all three. I don't play any favorites anymore on that one. Did that answer your question, Dimitri? Sure. Okay. I think the big thing to remember is that ClickHouse is a database. Presto is a query engine. It requires the data to be sitting someplace else, which is very good for openness and allows you to access that data from multiple applications. When you pull data into ClickHouse, it's only available in ClickHouse at that point. And that's the big difference between these databases and an open data lakehouse like that I'm talking about here. Any other questions?
All right, I'm sure someone out there has questions, since I know personally, for me at least, I need to watch this video at least one more time just to make sure I'm following along, because there was a couple of places I'm like, I need to do more research on that to even start to have questions.
Oh,
hopefully that's where most of our group is.
well, I'm
That's
happy
why
to
that's why I love these presentations, because I'm always learning more about things I didn't know even existed before. So, perfect.
And if anybody wants me to disambiguate anything that I mentioned, I'm happy to. It's hard to sort of set these levels, right, of audience. So.
Yep. It's like I said, for me at least, it's perfect, because I like to be questioning or even become aware of different things. So that's exactly what you did, which is what I was hoping for. I know enough about some of this stuff to be dangerous, and you gave me just enough information to be more dangerous. So perfect. But yeah, like Rachel said, if y'all have any questions, now would be the time to ask, no matter what level you're at. If you just have questions, what even the word means, that's also acceptable.
You're welcome, Eduardo. Let's see. I'm asked to populate Kafka topics from a connector to SQL Server. Oh, do you have guidelines when you need a warehouse versus a lake? Is the cost the only driver? I would say it's not necessarily the cost, but the value of your data. And what I mean by that is if you use a data warehouse, cost is going to take into consideration because you kind of have to pick what data is the most important to your users, and then spend the time to transform it, ETL it, and clean it up so it's useful. That's hard work. That takes a lot of time. So it's not just the expense of storing it, but the expense of managing that data. And then the flexibility that your data warehouse is going to have in handling new questions down the line or new data sets down the line. So if you have, and I think it used to be called a data mart, but a subject-specific database, a subject-specific data warehouse where you're going to be just providing, say, ad tech. You're just going to be providing analysis on, what ads should be shown. It's a very narrow use case. You need the data to be really fast. You know exactly what data you need. A data warehouse is probably the right choice there. Now, if you're going to be doing more like, hey, we're going to be doing more exploratory, or we want to be able to look at data in different places, or we have data that's of dubious value, that maybe it's JSON objects or XML data, and you're really not sure what's going to be in it and how valuable it is, a data lake is a really good option there. And a lot of people do both. They have a data lake where their data lands, and then they use a data warehouse to do very kind of pointed analytics off the data that they pull out of the data lake. And this goes back to the Kafka question. You can use Kafka to keep your data lake in sync with that data warehouse. So you don't have to move data to the data lake first and then to the data warehouse. You can say, all right, all the data goes to the data lake, and then a subsection of it goes to the data warehouse. And then you would do analysis and discovery of the data on the data lake in order to make decisions on what might need to go in the data warehouse or into a data mart. So it's not just cost. I think it's more value, and cost can be a factor of that as well, because I think a lot of people default to using Snowflake because it's there and it's easy to use, whereas if you could just instead of ETLing the data into Snowflake, ETL the data into Parquet files and put something like Presto or Trino on top of it, and then you'd be able to query it just the same as you would with Snowflake. A little bit more management, but your price is only the cost of the compute for ETL and for the queries, and the minimal cost for storage.
Well, I know, Rachel, in case there's more questions that come up, and I'm sure our people are thinking hard on more questions to ask.
Yeah, my email address. I have both my work email and my personal email in the chat. So you're welcome to reach out. Happy to do just a quick session with anybody, talk through some of these things. Can also do kind of a NoSQL primer, because I know that's new to a lot of people, like what the difference is between Mongos and Cassandras and that world. Oh, are Presto and Trino specific to AWS, or are they available on Azure? Well, they're actually open source. They can run anywhere. So they definitely run Azure, and they can run in AWS. They can run in GCP. They can run on your own box. They can run on my laptop, which they do. Presto and Trino are both completely open anywhere. Now, you have vendors like Amazon offers a version of Presto and now Trino called Athena, and that's just a AWS specific. Ahana, who's my employer, we offer a hosted version of Presto on AWS, and then Starburst offers Trino as a serverless solution. So there's a number of options there in the industry.
Keeping up with it is half the problem.
Yeah, exactly. Much less the Trino Presto kerfluffle, because it just confuses a lot of people. And at the end of the day, I just want people to walk away with, they both solve the same use case. Whichever flavor you decide to go with, of course, I'm going to suggest Presto because that's the original one, but I'm not, honestly, technically, they're not much different. I know, just to keep everybody on their toes.
Yeah, because open source is not hard enough to remember by itself. Now we have this. Yeah.
What about MS? Do you mean Microsoft or SQL Server, or what do you mean by MS?
Multiple sclerosis?
Yeah. Azure. Yeah, they oh yeah, Azure. I don't think Azure has a Presto or Trino solution. Oh, it says Presto on Azure. There looks like Integral is a company that offers that for and I think next week you guys are getting a talk on Synapse. I know Synapse did used to have Druid available to it, but I'm not sure if Synapse offers Presto or not. I don't think so. See, this is why you have to. Oh, it looks like Starburst brings Presto to Azure. So Starburst does offer Trino Presto to HD Insight. So you might find the Presto stuff in HD Insight. Use cases in the oil industry or energy. So these, I don't have one off the top of my head. I'll definitely look for a specific user for you, Eduardo. But the IoT is typically where we are going to see oil and energy using these types of technologies because IoT does require it's a lot of data. And if you want to if you want to take a look at analytics over multiple devices, you're going to need something like Presto or ClickHouse or Druid to do that type of analytics. So Presto would be a perfect solution for doing analytics over IoT data. In terms of OLTP for IoT data, time series databases or NoSQL databases, key value stores like Cassandra, I would recommend for that. But remember, Cassandra can't table scan, so therefore you can't use it for analytics, no matter what DataStax wants to tell you. So, Kevin, do you want to wrap it up?
Sure, let's go ahead and wrap up because I think everybody is at least partially let me and need to watch it at least one more time before we start asking questions because we know enough to be scared
That's cool.
or dangerous.
You're very welcome. Thank you guys all for your time and using your lunchtime to hang out with me.
Hey, no better way to hang out at lunch and learn about all kinds of goodness.
Okay.
So with that, we do thank you, Rachel. As she said earlier, we are going to have a meeting, another presentation here rather soon. I believe, no, it is next week. Let's make sure of what is actually out there for us. All right, so next week we're talking to Armando Lacerda on SQL Server backup strategies in Azure. So be sure to join us for that as we come along here to next week. And also please remember that we'll actually be having a presentation the week of Past Summit. If y'all are coming to that, please be sure to tap me on the shoulder because I will be there. I don't believe anyone else from the leadership group for DBA Fundamentals will be there, but be sure to reach out for me if you happen to see me. Tell me what you think, what we could look more for different presentations to have. And if you love having people like Rachel on, just let me know. It's all good. So with that, I do thank you all for your time. Hopefully we'll see you in the upcoming weeks on another presentation from DBA Fundamentals. On that note, we do thank you all very much.